good evening to everyone. I'm so happy that I'm a part of Sterlite Technologies Digital Limited. I've been associated with Vedanta and I'm heading IT and digital for Sterlite Copper. And more importantly, to say that I have 3 decades of experience, 2 decades in manufacturing and 10 years in IT. So here I'll be taking you through the journey of artificial intelligence in manufacturing. When you say that artificial intelligence in manufacturing, we are mainly focused to drive the 3 factors. One is the volume impact, second is the cost impact, and third is the turnaround time, and finally it comes the adoption, improving your revenue. The revenue plays a major role in scaling the artificial intelligence. So here I wanted to cite the complete platform. How does this platform gets operated in manufacturing? So to set up a AI-based platform, the most important is we should have a proper sensorization. So it is mainly the IT/OT systems which will help you to set up a full roadmap, complete integration with your plant technical systems and also with the IT systems. Here we have, mostly importantly, I wanted to say about the distributed control systems. In olden days, we had a DCS, and olden days we had advanced process control. But if you ask me that, they were not smart enough to throw your data into the data lake and also give proper information and the proper outcome of the complete the data which is being utilized in the plant operation. So if you ask me that, more importantly, coming to the sensorization, if your equipment is not having the sensors, it cannot read the data and you cannot have any outcome and you cannot put any artificial intelligence into your system. The most importance I wanted to tell about the predictive maintenance. In these days, we talk about the predictive maintenance and also the prescriptive maintenance. When you go to doctor, the doctor gives you medicines and he gives you some prescription. Same way, I wanted to say that equipments also record same kind of thing. I'm running a big smelter. Example, the smelter requires to be monitored predictively as well as prescriptively. So if I ask you, like a pump is operating for so many days, what is the mean time duration the pump will operate it, and what is the design parameters that it can do its operation continuously for next 3 years. After that, I have to change the equipment. So how do I get a prediction? I get a prediction based on the condition-based monitoring and also prescriptive maintenance. So based on this, I am able to take the decision on right time. So because of that, my maintenance cost will be coming down. And this is the most important factor that all of us has to notify that predictive maintenance is an effective thing in the factory automation. And second thing is the demand forecasting and the supply chain automation. Suppose, for example, I am producing the product, okay. So if I'm not having a proper plan to sell, if I'm not sensing my market based on the AI, there are a lot of AI demand sensing tools which is being available in the market. These tools helps you to identify your markets, and from that you will be able to find out your customers, and then the product selling, you can make a roadmap. Similarly, when I say that, for my operation, I wanted to bring some raw material. The raw material has to be blended properly to get a proper outcome. So here I can say it is a volume impact. So your recovery or any other your product outcome, it should be basically meeting the customer need. So basically what you have to do is you have to have a proper keep it here. I wanted to have a proper simulation based my raw material blending model. So that is also most important to improve your volume impact. Here I just wanted to share some global learnings from the manufacturing companies. You all know that BHP Billiton is a company, metals and mining company. They are operating their DCS and control systems and their engineering team is sitting away and 1,300 kilometers. They are operating the plant away from their place. For example, like I am sitting here and 1,300 kilometers away, I am operating the plant. So that is most important thing, which is to notify. Similarly, the Rio Tinto is another smelter. So the Rio Tinto is also, they are also having their safety sensors, and they have done a complete sensorization and all the actions and also the predictive controls, the complete action is being taken based on that. And because of their thing, 50% of the benefit they have got it, okay. So coming to the digital twin is the most important factor for the plant operation. So when I say a digital twin, unless you sensorize your plant operations, you will not be able to do a twin. For digital twin, it is more important that minimum viable product, MVP, is most important. So for this, the design data and other things are also a prime factor, and the historic data is also the another prime factor. Unless you guys have the historic data, you will not be able to have a proper digital twin, because based on the historic data, the twin is getting model based on the machine learning based models. We have a lot of platforms, like which you can do EDA, extractive data analytics. For example, there are platforms like GitHub is there, and also Jupyter Notepad is there. There are a lot of platforms. Okay, so you can develop your engineers. You can have a cohort of different teams, to build this machine learning based model. There are partners who can do also, but it's better to develop your in-house teams also to some extent, so that they can develop models. So the most important factor of the digital twin is doing a MEP based model. So the digital twin will mainly tell about your process issue. It is like, for example, you have a physical plan, big plan which is running, but that how do you manage such a big plan? So the twin is another, it is a cloning of your plan, which helps you to identify the process parameters, and more importantly, it helps you to find out abnormalities wherever it is happening, and it sends an alert to the shift operator. So the key features of the digital twin is, first, the sensors, second, the data, the real world operational environmental data is picked from the various systems. How do you pick these data from the various systems? Because there are a lot of connectors which is available. You have to build a data lake actually. So there are a lot of data lakes which is available, and we have a Azure data lake, and after that the integration of this is being done, and analytics is the main outcome. So machine learning and the AI based models are helping us to do the data analytics in a more effective way. So this data gives us a decision making model for our plan. I already told you that main important factor is the volume impact. So this helps us to improve our volume. And second thing is, like, you should have a quality management model for your company. For example, if you're a automated, your company may be automated, or you might not have sensors or this thing, but you should see that, how the quality management is being done. For example, you can put a ML based model for your quality management. So that will help you to reduce your rejections, and also, like, you can put a chatbot which interacts with the customers. Okay, so the customer data, what are the issues the customers are facing can be analyzed in a right track, and we'll get a proper outcome. So these kind of analytics, helps us to improve your quality and also the plant operations. So the digital twin concept and also the complete quality management concept helps us to build a robust plant operations with more effective operations and having a volume impact. And another important concept I wanted to bring it here. Most of you might not be knowing the concept of the smart fuel. Okay, so when I say smart fuel, you have a big furnace. When you are putting some material inside, okay, that requires this much temperatures to automate that thing. So how you control your temperature? For example, in these days, furnace oil, HSD, so many things are there. Okay, so you have to have a small machine learning based model based on that design specification. This much is the oil consumption I can allow in the system. So that helps you to control, and obviously it will lead to a lot of cost impact, and you will save a tremendous amount of money. I can say like $2 million can be achieved because of this sensorization and also the smart fuel. So next. This actually, yeah. So, like, I wanted to tell about ESG and sustainability here. Most importantly, we all have emission data. This emission data can be, machine learning models can be built to analyze the emission data and to have a control. And also, the most importantly, I just wanted to bring in pitch in carbon footprints also. So, when we have a energy monitoring systems, and where we have a complete, energy management which has been integrated with the data lake, that helps us to analyze the complete data, and you will be having the complete integrated system wherein carbon footprints also can be monitored. This carbon footprints actually, it helps you to gain your CRs also, and you can the United Nations Climatic Convention is there. So obviously you will be able to get the carbon credits also. So it's a main important fact which you can try for. And coming to the safety, we should have a detect technology to analyze the behavioral based safety and other safety measures. So like detect will completely help you to automate, and also like you have to annotate all the unsafe practices, and helps you to completely automate it. Okay, so complete these integrated systems and also the digital twin concept helps you to have a smart manufacturing. And more important thing is you have to scale the platform in a very, very right way. You have to brainstorm and you have to find out the proper data, and you have to build the complete analytics which can help you to compare with the historian, and also give the right real-time data, and the plan gets operated in a more effective way. Okay, but basically artificial intelligence we are talking about, but the real human intelligence and the real brainstorming and Google's way of 10x power of thinking will help you to build a better digital twin models. Thank you.